Hi, today we're going to talk about variable resistors. This presentation is going to go between a live demo on the DocCam, multisim, and a PowerPoint presentation. Okay, so don't worry about the multimedia, it's all going to be the same price. Okay, so variable resistors. What we have is usually a device that has 3 terminals on it. Okay, it usually has 3 terminals. 2 terminals are a fixed resistance, and 1 terminal is the variable resistance. So it's usually terminals 1, 2, and 3, and terminal 2 is usually in the middle. So here are some examples of variable resistors. Okay, and what we have here is, if we want to see some real life examples, is we have this. Okay, so we have a resistor, a standard variable resistor, 3 terminals. Okay, this is something you usually find in a radio or an older piece of equipment. And it has a little threaded shaft so you can mount it to a chassis of some kind. This is a very old variable resistor, but one that we're going to use for demonstration purposes. It's perfect for it. And these are what are called trim pots that are usually mounted on printed circuit boards. Okay, and what we have here is the schematic symbol for a variable resistor. And we're going to show you more about that coming up. All right, now the anatomy of a variable resistor consists of a resistive element, which are between terminals 1 and 3, between pins 1 and 3, okay? So this is usually a resistive wire or resistive material that has so many ohms per foot. So it's a fixed resistance. And then we have the wiper. And the wiper is what moves along that to give us our variable resistance. So again, terminals 1, 2, and 3, there's usually a screw or a shaft that moves the wiper. Sometimes it slides across. And we're going to switch to our example here. So here we have a very old variable resistor. Okay? A very old variable resistor. So we have pins 1, 2, and 3. Okay? And if we flip this around, we see that between pins 1 and 3, we have this resistive wire that's wound around a core. Okay? So this resistive wire is a fixed resistance. So this particular unit here is a 100 ohm variable resistor, which means between pins 1 and 3, you're always going to measure 100 ohms. Okay? You're always going to measure 100 ohms between pins 1 and 3. Which is what we have there. So now, in this resistor, in a variable resistor, you have your fixed resistance across the entire unit. And then you have the wiper that moves across. So what happens here is, as this wiper moves, you actually have a resistance between pins 1 and 2, and a resistance between pins 2 and 3. And resistance of 1 and 2 plus the resistance of 2 and 3 is the same as the total resistance going across. And as this moves back and forth, so that if it moves to the left, that means the resistance between 1 and 2 gets smaller, and it moves to the right, it means the resistance between 2 and 3 gets smaller. So if 2 and 3 gets smaller, then 1 and 2 gets bigger. Okay, so what we're going to do here is we're just going to bring another ohm meter onto the scene. Okay, we're going to bring another ohm meter onto the scene to measure resistance. So we have 100 ohms approximately between the two. So I'm going to measure with 1 ohm meter pins 1 to 2. And with the other ohm meter, I'm going to measure 2 to 3. All right? I'm going to measure pins 2 to 3. So what we have is 12.6 plus 86.6. Okay? So we're up in the 98 range. So these will always add up to close to 100. So here's my resistor. So right now, the resistance between these two pins, okay, which is on the meter on the left, is very small because the wiper is very close to that pin. As we move the wiper away, all right, this resistance increases and this one is decreasing. So I'm just going to move it up a bit so we can view it all at once. Okay, there. So let's move this along. So as I move it, the resistance changes between the two pins, but it always adds up. Okay, so right now, 68 plus 32. All right, so we have our 100. So this will keep changing. And as we move closer to the one pin, now the resistance between here is very small, which we see at 1.2 ohms. And the resistance going all the way around to the other pin is very large. If I go halfway, or what I think is halfway, okay, then we'll start to almost even out a bit. Oh, I'm close to halfway. All right. So we'll just keep moving those. And then that's how a variable resistor works. You have a constant resistance from pins 1 to 3, and you have a wiper that moves along it. Okay? There's always a resistive element and a wiper that is connected to pin 2. Okay? This is my favorite variable resistor for demonstration purposes. So, we also have different levels of precision when it comes to variable resistors. So the one on your left is a single turn variable resistor. And the one on the right is a multi-turn. So what happens is to go over the same resistance, or to go over the same from pins 1 to 3, pin 2 will have a more immediate, it'll have a more immediate motion from pins 1 to 3, where on a multi-turn, it'll have far fewer, or it'll move a lot less distance if we turn the screw. So what I'm going to show you here is, I'm going to go back to our camera. There we go. So we have our multi-turn, and it has 3 terminals, pins 1, 2, and 3, and the adjustment screw on the end. And we have a single turn trim pot. Okay? So what we're going to do with the single turn trim pot, we're just going to place it in here. We're going to put 2 of our conductors in there, and we're going to measure the resistance as we turn the screw. Okay, so let's connect our ohm meter like so. Very nice. So if we see here, we're at 10K, and here's our adjustment screw. This is the range of motion that it travels. Okay, so in one rotation, or not even one rotation, it goes from 10K down to 0. So if we're trying to get something accurate, it's going to be very difficult. Okay, it's going to be very difficult because our value jumps so high at the slightest movement of the trim pot. Okay, so it's very difficult to be precise here. If we took the multi-turn trim pot, then what would happen is, I'm just going to move this over, okay, and we're going to place this in the breadboard. So there's my reading. Okay, we'll get the wire out of the way. There's my reading. So watch the screwdriver as it goes. So we're here. Look how many times the screwdriver is turning. Okay, it's turning multiple times. So I can actually get this pretty accurate. I can actually get it pretty accurate. Like I'm only jumping here by 10 ohms at a time. I can never get that kind of precision on a single turn trim pot. All right, I could never get that. So that's just two ways of achieving precision on these things. Now, to know what value a variable resistor is, okay, a lot of times it says right on the unit. It'll say right on the unit. If you're using a trim pot, you'll see a code, a 3-digit code. So this is 103, if you see in the middle there. This one here is also 103. Okay, if you look at the package, you'll see a 103 on it. This one here is a 102. So 102 means 1 0 and 2 zeros. 103, which is 1,000. 103 is 1 0 and 3 zeros, which is 10,000. So it's 10K. But if you can't read the value and you want to know the value of the variable resistor, all you need to do is measure across pins 1 and 3. So if we get this here, okay, it'll show us right there what the value of this variable resistor is. So in this case, it's a 10K variable resistor. This here, okay, somebody just happened to write on it that it was 50K, but it actually says 50K indented in the package. But again, if you don't know, you just measure pins 1 to 3. Measure pins 1 to 3, and it will tell you. So it says 47.4K. All right. And then with our demo unit, the one that my great-great-grandfather gave me, again, we just measure across. We know it's 100 ohms, but if we just measure across, it will say 100. Okay, so that's how you determine the value of a variable resistor if you can't determine it from a reading on there. All right, so variable resistors are configured in two modes. Mode 1 is as a rheostat, okay? So a rheostat means is that it's placed in series and it is set up as a current limiting device, okay? It's set up as a current limiting device. So what that means is if you have a function, say like a dimmer, if you have a function that's like a dimmer, okay, what you would do is you would set your variable resistor up as a rheostat. All right, so what that does is you would take pin 2, and you would tie it directly to one of the terminals. So pin 1, pin 2, pin 3. So you tie it directly to one of the terminals. So what happens now is the resistance between 2 and 3 is always 0 because they're shorted out. So what we have here is our source, our load, say it's a light bulb, okay, and our variable resistor. So what happens here is as I adjust pin 2, the resistance between 1 and 2 is going to go from 0 to the maximum value of that variable resistor. All right. So this is now, in essence, like we could say in this case, a dimmer, but we're just using it as a current limiting device. So it's affecting the current of the circuit directly as an in-series resistor. Okay. And if we just hop to multisim for a second. There we go. Here's how we have it configured. So we have our voltage source. We have our variable resistor with pins 2 and 3 tied together directly. And then we just have a load here. And so what we're doing here is as we adjust this, it changes the resistance of this, which in turn changes the voltage going across the load. Okay? So that is set up as what's called a rheostat. This is a very simple setup. Now, our other mode of connection for a variable resistor is as a potentiometer. Okay? It's set up as a potentiometer. So what a potentiometer is this is when a circuit is set up to be used as a voltage divider. All right? So we're just going to go to an example here. So as a voltage divider, we have E, as we always have, okay? Let's just call this R1. And then we have our variable resistor in our circuit. Okay? So our variable resistor, pin 2, is usually tied to a load or another part of the circuit. So this is the load, okay? So what happens here is, depending on where this is in the circuit, depending on where it is, you have a resistance from the wiper to R1 and a resistance from the wiper to negative. All right? So this is pin 1, 2, and 3. So this circuit here is equivalent to this. Okay? So we have R1 again. We have R1 again. And then we have, if we were to do this, we have this. We have this resistance here from pin 1 to 2. And then we have this resistance here from pin 2 to 3. Okay, this is R2. And then here we have our load. All right, so let's call this, to keep this organized, R2A and R2B. All right, so this resistance of this circuit is going to be, the resistance of this circuit is going to be R1 plus R2A plus R2B in parallel with RL. Okay? So what happens here is as we move the wiper, R2A changes and R2B changes. So now the value of RT is going to change, which means IT will change, which means VR1 and V of the top half of the variable resistor is going to change. So the voltage across RL will change. It's a little different than a rheostat circuit, okay? And the reason why it's different is this can be used to precisely set what we want across RL, okay? And if we change RL, then we just adjust this here. An example, since you asked, is, I'm gonna go back to multisim, all right? I'm gonna go back to multisim, and this is what we have here. So I have a resistance another resistance, a variable resistor here set up as a potentiometer and a load. So if I want, I'm just going to set this to be a little more precise. Okay, increments of 1%, nice. Now, stop that one. Let's start the simulation here, okay? So suppose we wanted the voltage across the load to always be as close to 5 volts as possible. So what happens here is I can adjust R1. Okay? So right now it's 3.495, or I go the other way and it is 5.28. So I can slowly adjust, all right, until I get the voltage I want. All right, I could slowly adjust that to get the voltage I want. Now, if I change my load, let's stop this and let's change the load. And now suppose I change it now to 2K. All right, I changed to 2K. So what happens now is RT has changed, which means IT has changed. So we need to adjust what we have here. We need to adjust what we have here. So here. And I could set that voltage to wherever I want, okay? I could set the voltage to wherever I want. And you'll see sometimes when you, so let's adjust, okay? Okay, so we're hopping between 4.917 and 5.093. So we're zooming in on there, okay? We can do something a little more accurate. So you would design a circuit that would allow you to adjust the voltage across the load. Okay, so this is when a variable resistor is used as a potentiometer, which in turn is used as a voltage divider. Okay, so you're going to hear those two terms used a lot over the next few years: potentiometer and rheostat. Okay, you're also going to see these referred to directly as a potentiometer. So when you see these in catalogs or magazines, okay, you'll see this a lot of times called a potentiometer, which is a lot of times is what it's called. All right, but this can be configured as a potentiometer and as a rheostat. It's important to know the difference, how they're used, when they're used, and next term, lab 1 is incorporating rheostats and potentiometers to set up a voltage output that you can have a minimum and a maximum that you set, and then you have one that sets the actual output. Okay, so that's what I want to share with you today about variable resistors. They are important devices to know how to use. You do need to understand how they work. You need to understand how to measure the resistance across them, how to determine what value of variable resistor they are, and how to design circuits where you know the maximum and minimum values that can be set to, and make sure you're putting the right device in there so you don't reach a limit somewhere. Okay, so we'll see you next time and have a great day.